All right, welcome back. This is our third video on learning React. The first video, we just had a little bit of an introduction, talked about how we were going to set up the React development environment to begin with. And then in the second video, sort of a part one, we developed a little bit of a simplistic toy that we could play with here. And if you're following along, um, what we're going to want to do first is to sort of reset a little bit. Now you can follow along and make all these changes to the code with me, but if you have the Git repository, then you'll notice a couple of things here. Let's take a second to just to see what's going on here. Um, this little dot, by the way, means that there's unsaved changes. Let's make sure everything still works. And we can still swap things around. Um, you'll notice that there are these little M's here, and when you hover over them, they say modified. You also notice down here this little symbol. It says chesslab git part 0. So what that tells us is that Visual Studio Code is hip to the whole Git scenario. It knows that this is a Git repository, and it knows we have a couple of pending changes that are not yet committed. And from this point on, if you've got your own Git repository in GitHub and you want to commit your changes there, you can sort of work within Visual Studio's code right now, commit your changes, and then push them into your own repository. For the purposes of these videos, what we're going to do is a little dance at the beginning every time where we sort of go back to the baseline and check out the next branch. So let's go ahead and I'll show you how to do that. And it's pretty straightforward to figure out and get how to add your changes to stage them. Here you can see if you click on this guy, you get a different view of everything that's been modified. And you can stage those changes, and then once your changes are all staged, you can make a commit that then you can share with other people through GitHub. But if you don't want to do that, what you want to do is follow along with this video. Then it's pretty easy to sort of reset everything, because Git just keeps track of changes, and it allows you to go back to where you were once if you decide you don't want to keep whatever changes that you made. So in order to do that, let's go ahead and quit out of our development server here, and to do that you hit Control C. We're going to use the command line here with Git because it's pretty easy to use. I think you'll see that it's just a few commands in order to switch branches. Let's see where we are right now. Git branch will tell us the list of current branches. So we have the master and we have part 0. And now what we want to do is check out part 1 and start working on that, and we'll work our way towards part 2 from there. So right now, if we try to do that, we're going to run into a little bit of a problem. It's going to tell us, let me show you what happens. Let's do git checkout, or git fetch origin part 1. There we go. Now what we did there is just said to Git, make sure you've got a copy of this branch from GitHub. And it hasn't necessarily done anything with it yet. In fact, it probably won't even list it if we type git branch. So we need to check it out. So if we do git checkout part 1. Okay, so what it's telling us is we got unstaged changes. It doesn't want to blow away what we've done and stomp all over it. It actually gives you a good idea. You can stash them. There's a couple of ways to do this. If you wanted to stash your changes, if you just type git stash, then what happens is it is going to, you'll notice things changed over here in Visual Studio Code when we did that too. Now there's no changes. If we do git status, our branch is on part 0, git branch, Everything seems cool. It looks like we might have even lost our changes, but that's not the case. In fact, all we have to do is type git stash. Well, actually, we can probably list what's in our stash. List. Yep, we've got something in there. So if we pop it off the stack of stashed items, then all of our changes come back. So the stash is sort of this place where you can keep stuff a little bit off to the side and you don't have to deal with it just yet. And you'll notice all our changes are back now. But if we don't want to use the stash, let's see if our list is empty now. If you don't want to use the stash, it makes a lot more sense a lot of times to just get rid of stuff. And the way to do that is to simply check it back out again. So if we do git checkout source app.js, then now if we do git status, you'll see we got rid of that change. We're back to the baseline. And we want to do the same thing with this CSS file too. Let's do git checkout source app.css. Okay. Git status. And we're good. So now it tells us there's no changes. Let's go back into our Explorer. It looks like Visual Studio Code. Oh, here we go. I just scrolled down. It's such a smaller file now. So we're back to sort of the original state. Edit this and save the file to reload. This is what we got out of Create React App. So now we can run our checkout again. Git checkout. And we can specify our branch name, part 1. There we go. And Visual Studio has already picked up all these changes. So this reflects what you would find in GitHub on this branch. And sure enough, we can type git branch and see that we're on part 1 here. Visual Studio's code picks that up too. And we can see what branch we're on. And we can even now run npm start. Make sure everything still runs correctly. And this is our old one. We can close this now that this new one's up. Looks a little bit different. Cool. So allows us to swap things around. Everything seems to be working. Now the point of this video is we're going to talk about sort of a React way of proceeding with building a program like this. And it also helps to talk a little bit about sort of the day-to-day of programming. You might have gotten a sense for this already, in which we're kind of whittling away at the problem here, and it helps to be able to see what the next step might be. A lot of people find that really tricky. Some of the best programmers aren't necessarily good at programming. What they're good at doing is taking a problem and seeing the path to get to the answer. And the path is a lot of little steps where you're making a little change. And so the next thing can be really obvious to some people, but the next thing might be there might be a lot of ways that you can go. We'll talk through this a little bit. We've got a really simple chessboard here. So one place that you might think you could start is, it doesn't really make sense that we can move a piece where there isn't one. I mean, it doesn't make sense to move the dash piece, right? So, or maybe it doesn't make sense to be able to move one piece onto another if they're the same color. So maybe it's most obvious to start developing a way to have some rules in this game. And if we just sort of fill in a few rules, then that gives us the ability to come back later and make those rules more filled in if we want. we could put in a rule here or there just to, you know, give us a spot to have certain rules. So what we might want to do is say, well, you know, there's a couple of different classes of rules. Like there might be a rule that could fit inside a different part of this if-else block. So we've got these three different if-elses. And one of them, this last one, is one that's sort of a default where we're saying, okay, we're just clicking on something for the first time. We haven't clicked on anything else before then. We're not clearing the state and we're not moving a piece. But what we're doing is we're clicking on something for the first time. So what we could do is we could add a check for, or maybe we clicked for the first time on something that, you know, doesn't even make any sense. So you might think to yourself, well, I could just encapsulate that here with an if check, right? I think it makes more sense to have an else if here. And we can check for the value being a dash. Okay, so now if we've got a blank space, we could just I think we could just return, ignore it, and we'll just quit out of this whole select adventure. Let's see what happens. Oh, we can still select that one, so that didn't work. Oh, I wasn't able to select that one. I think our bug is rearing its head where we have a situation in which one of these cells may have a space and it's not being detected properly. Let's test that assumption a little bit. What we could do is print out the value. Let's do console.log, and we could just say value. And then since we're looking for some white space there, we can even put something afterwards just to highlight the fact that we've got maybe a space in there that's preventing our check from working. Okay. Let's go ahead and open our developer console. And a lot of people forget when they're learning to program, all you have to do is hit Control-Shift-I or C and try one of those and it'll usually bring it up. Let's see what we get. Yeah, look at that. We got spaces in there. So I bet if we can not select this one, yeah, look, there's no spaces there. So the A1, here's A, and here's A1, A2. It's dropping all of the spaces out of that one, but it's leaving them in this one. So there's a couple ways to handle this, but probably the most common way is to deal with it right here. And you can sort of play around with this in a node environment. Let me make this a little bit bigger. Let's pop open node. And we'll do a string value equals like that. Okay. So this is the thing. What we want to do is check. Let's check string like that. That's our check. Obviously that's false. So what we could do is we could just manipulate it to remove any of these spaces, which is easy enough. I think the easiest way to do this is just to use a regex with a replace. So Node has the facility to say string dot replace, and then you can just put a regex directly in here. We'll just use a space G, and we'll do replace with the nothing. So this says to detect a space, and G means anywhere in the string, so if there's more than one, it'll get rid of both of them. Actually, let's see what happens if we don't include the G first. So see, it finds the first one and gets rid of it, and then it's done. but if we include the G, gets rid of both of them. So this is a really common thing in programming. It's pretty common to find that spaces pad out little strings that you're trying to detect. So it's not unusual to want to clean things up a little bit. And then we can just do a string equals string like that. So now our check for equivalence is true. There we go. So what we can do is we can just Control D will quit out of node. And we can copy this little bit of code directly out of... We know it worked, so it makes sense to just copy it. And we can do value equals value paste. So now if we save this, yep, sure enough we can swap these around, but now we can't select either of these. Okay. So that's one type of rule. Another type of rule might be, you know, we're moving into a square. That's this case. And it's a lot more common in chess for there to be limits on where you're moving. This is the only rule I think we're going to have where we're selecting something. We could have a rule like if it's your turn or not. But rather than do that right now, let's focus on this chunk of code here. What we want to be able to do is say, is black moving onto a black square? In other words, you can't take a black pawn with a black bishop, and you can't take a white pawn with a white rook. So what we want to do here is just a little check. And the trick is going to be looking at the value that's actually being copied into where we're going. So we need to capture that variable. Let's call it initiator. That's sort of what piece is being moved. And we can store it in that variable just by saying row 1, column 1. Okay. So now that we've got that, we want to do a check for, is that piece the same color as another piece? And if so, then we want to forget doing this whole move. So in the first case, we don't want to check for any kind of color if it's a blank space, right? So we got another check here for is the value not equal to the dash, okay? So otherwise it doesn't matter. In fact, in the else block, at some point in the future, we may want to have a check for, can this piece even move this way? We don't need that right now though. So let's think about this. We want to get the color of where we're moving to and the color of where we came from. So first let's get the color of where we're moving to. Let target color equal value. Now value is going to be something like WQ or BQ. So let's check for the first letter. So that's going to be W or B. And then we can do the same thing. Let initiator color equal instead of value, now we're looking at initiator 0. So now we've got both of their colors. We can do console.log. We could say something like from target color to initiator color. Okay. Let's see how we're doing here. So we won't print that if it's a blank space. Good. But if it's the other color, look at that, from B to W. Okay, so that's good. Let's do a check here. We can get rid of this. If, and what we want to do is compare target color to initiated color. And I think we can just bail if they're the same. And I think that's okay because we haven't set any state or anything before this. There's nothing we need to sort of clean up if we bail. So I think we can just safely have these. These are two different scenarios. In one scenario, we're detecting another kind of generic case. It's still a rule, but it's very generic to the problem. In this case, it's sort of this sub-problem. Okay, we're moving to somewhere. Do we need to bail? And in the future, what we might decide is to make these rules a lot more complicated. Not only color, but does this attack make any sense? Is this piece's turn, or is this piece allowed to attack in this way? In chess, it might be common to check, does this move put my king into check? And if so, disallow that. If we were making a commercial product, a lot of these would be important considerations because it's sort of what people expect out of that kind of a game. A lot of people don't necessarily like it that a chess program would let you move in any way. But for our purposes, we're creating a toy, so we can make these rules as simple or as complicated as we want. This is sort of a placeholder rule for now. So let's just leave that in place and see, kind of make sure that it works. We're able to swap places, so that's good. And we can't sort of swap when they're blank spaces. But at this point, there is something that we're not doing. Clearly we can swap, but we're not capturing. We can move there, but in order to capture, what we want to do is set where we were instead of to being swapped with what we've got. We could just set it to our blank marker. Let's try that. So now we leave a blank where we were, no matter what. There we go. Black wins. And you might have detected the fact that black has won here in this case. You could write a more complicated program where you keep track of wins and you detect the win state here with some kind of a check. Were all the pieces eliminated on one side could be a way that you could detect a win, or was there 3 of the same moves in the same sequence that causes there to be a draw automatically. And you could have a scoreboard that sort of keeps track of how many wins and resets the board, but we don't want to get this too complicated yet. Some of this is we're just drawing the outline of our program right now. Later we want to come back and maybe pull that kind of thing out and say, okay, let's work on a scoreboard now. But we don't even have sort of the whole board yet. In fact, there's a test case that we can't even test here, which is we can't test the fact that we're doing 2 at the same time. So in other words, we can't test that black can't capture black or white can't capture white. So in order to test that, we're going to need to alter our board, and it doesn't make a lot of sense to keep using this little hard-coded board. What would be nice is to actually have a board that we don't want to have this repeated code over and over again, because whenever you have code that's repeated over and over again, that's an opportunity to have just one little difference, and maybe you forget the S on this last one and you don't notice, or maybe you forget to add a feature to one of those squares and that's the only square that doesn't work correctly. It's just sort of a bad idea to repeat this, we would have to repeat it 64 times for the full chess game, because there are 64 squares on a chessboard. So we don't want to do that. Let's make it handle a board of any size. And in order to do that, what we're going to want to do is have a loop that can loop through each row and then loop through each column of each row. And if you've done a lot of programming already, then you kind of have a sense that somewhere around here we're going to have some kind of for loop where we're kind of going through rows, and then inside that loop we're going to have another loop, each column in that row, right? And then we'll have a sort of a div that surrounds each row, and when we loop through here, we'll display a cell or a square of some kind, right? Okay. So what we need to do is figure out how we've got this whole display thing where we're rendering HTML. We can do these if statements. If this thing is true, it's going to display this. And we can substitute in things by just using this notation with two brackets. So what we need to do is figure out how React gives us the ability to loop through stuff. And sure enough, React has this ability. And it's typical for React. We have one of these little matching things. That's par for the course with React. So we drop out of HTML mode. We're in JavaScript mode. And the way that React wants to do this is with a map function. So it's very similar to a loop. But what you do is you take your array and you call map on it. So we're going to do this .state.rows.map. And we're going to do a special type of thing where JavaScript has these special function definition things. We're going to say row and row num. And this function is going to get called every time there's another row. So this will have the effect of looping through each row. And we're going to have the ability to have an index from row number. And this is going to be the value of each row. And in our case, it's going to be a whole array unto itself. So once we've got this outer loop, we need to do our inner loop. And instead of a for loop, we're going to do the same thing, and instead of saying this dot whatever, we're going to say row, okay? Because we want to loop through that row's array. And it works the same way. It's dot map, we say column, and we say we're going to get two things from this column and call num. And once again, that's going to be an index for each row. But in this case, each one of these things is a column in our two-dimensional array. So we've got a two-dimensional array here with where each of the rows is its own array, and each one of those values is a row. So now let's see if we can do that. And what we'll do is we'll do class name equals self. That'll look the same. And in here we can do, you might have guessed this already, but we can just say column. So we're getting the value directly out of our little matrix. That's it. And sure enough, now we have two versions of the board. This one we can't do anything with, this top one, because that's being generated here, and we haven't done any on clicks or any of this other stuff. We haven't moved it, but at least we know it works. And I bet if we move some pieces around, I bet it'll show us both of them. Let's see. Yep, we can move that around, and it duplicates it. So that's good. So now what we want to do is move up all of this stuff that we're doing here into this dynamic thing. Now, one of the ways to think about this in React is that this is really a thing. It's not necessarily just a chunk of HTML that we want to deal with. We want to maybe encapsulate that. And we can pull that out into its own thing that we can separate out. And one of the ways we can do that is just, you can just make, we can come up here before we return. And React has a way of making your own little tags. And whenever you use that tag, it's going to operate on it in a way that's similar to this whole class. So the way that works is, let me just show you a little bit of an example with this. And we'll get this to work in the simple class first, and then we'll pull all this stuff out and start just moving it into this. Okay, so we're gonna make a new type of React thing, and a React thing is really simple. It's just a named thing. You want to give it a capital letter, otherwise React is, I don't think it works if you don't have a capital letter. But we can call it a cell or a square or something, and that thing is going to be a function that takes props. And what we can do is we can have some stuff, and then we can return a rendering. So we can have a div here, and we can do class name equals cell, and then here, instead of just having call, right, we're not going to have call. What we're going to do is we're going to get passed a props. And React is going to do that for us every time we render a new cell. So instead of rendering a div here, what we'll do is we'll render a cell, and instead of putting the cell in the body like this, we're just going to have a little property here called call, and we'll set it equal. So what's going to happen is when React makes this cell for us, it's going to call our little function here, and the props are going to have anything that we put there, and we can access them just by saying props dot whatever. So in our case, we've got call, and we're just passing that right through as a property. So hopefully this will work the same way. I don't think we have to make any changes. Let's see. Same as before. Yep. Moves them both. We can't click on that, but we can click there and we can capture. Okay. So now all we have to do is get rid of all of these down here, and we're going to take these features and move them up into the body of this special little React guy. And you might have started to notice this is sort of the basis of React. Whenever we want to make another little piece of our web page, we can just reference that piece, put it where we want it, and then now we can just work on this. We don't have to mess with all this code down here. And the nice thing is that that means we can reuse this very easily. And we could reuse it in other places too, which we'll get to. But for now, let's port this over. So first we need to port over our on-click so that this works. And we'll copy that. Actually, I probably don't want to delete that yet, but let's copy it. And then we can put our on-click up here. And now the nice thing is, whoever writes this thing, they can just write it. And whoever uses it, if this is another programmer that's saying, okay, I'm going to write a page and it's going to have a cell in it, two people can work on this at the same time a little bit more easily. And the person working on this sort of doesn't need to care about all the little details happening in here. So what do we need for that? We need an ID. Let's see. ID. And what we're going to have to do is figure out what our ID is. Because in this case, we hard-coded it. But we've got to kind of transform it from the matrix location where we are to be the board identifier. So we have this play again of we've got an A1, we've got a B1, but really that corresponds to a matrix location of 0, 0 or 0, 1. So first thing we need to do is feed through our indexes. So we can say row num equals row num and column number equals column num. And now we can access these up here. And so we'll want to make, let's do a const ID equals. Now, we don't just want to take row number and column number, but we sort of want to undo the fact that we have this car code at thing here. It's sort of the opposite case. We're kind of re-encoding the value so that we can have IDs that are, in the end, we want them to be the human readable part of the chessboard. And you might disagree with how I'm implementing that. Some people would create a situation in which they would just sort of mask this off from the user and not involve this matrix change. But I think by having this matrix encoding and decoding step in our code, that'll enable us to, in the future, add features a little more easily. Like, for instance, let's say somebody wants to save a game or load a game from another platform. It's probably more common for that platform to export a game as a list of board moves that are using the chess coordinate system. If we can really easily handle the difference between our matrix and the standard chess coordinates, then it's going to be a lot easier to display those coordinates or read them from somewhere else. So let's use our ID here, but we've got to figure out how to sort of encode that ID, and it can help to go back to our node window here. We've got, what we need to do is come up with a way to encode something as ASCII. And if you Google that, you'll come to a Stack Overflow page that says something like, you can just call the string function from car code. And so we could do 65, for instance. That's the value we know that to be A. Sure enough, that works. And then 49 is the one for 1. So if we do 50, then we're at 2. So what we really need to do here is just sort of the opposite of what we did up here with car code at. Let's do string dot from car code, right? And we're gonna do 65, and we're gonna add our row number to that to sort of undo this move. So we want to do, we should have access to that from props dot row number. Okay. And then we should be able to just concatenate these strings together by doing the same thing, string.from car code. And we'll do 49. So that's the digit 0 through whatever, props dot column. So we already know that we're only going to have 8 of each of these. Technically, we could make a chessboard of a much bigger range, but what you'll notice is because we're using these ASCII codes, we would be limited in the number of rows by the fact that we would end up with symbols going past Z. I think we would end up going into lowercase letters first, and then we would go into alternative characters, and then we would fall off the end of ASCII codes. And in the case of the numbers, we would collide with A once we got to 65. So that's only about 16 potential columns. But I'm not planning on making a chessboard with 16 columns, or I'm planning on making a chessboard that's 8 by 8. So now we should be encoding our ID correctly. We could print it out here. We can just test it and see what happens. Let's see. It looks like it's working. Actually, that part works, but we don't know if we can we click up here? Ooh, look at that. So what's happening here is it's working when we click up here, and it's affecting down here, but it's also using the board reference thing in order to highlight that box. So we've got to fix that too before we can get rid of this. I think we can do that in the exact same way, just by, let's make this a little bit easier to read for now. You can just have this all in one line too. We can just copy one of these reference things. Copy that. And paste that there. Okay. But now instead of having this hard-coded value, what we really need is just to use that ID as a reference. There we go. So now we set that reference. Now, instead of having multiple IDs and everything, we can go ahead and get rid of this entire chunk now. There we go. And so now we've got every row has this outer div, and then every cell is a cell, and it's going to set up our ID, and it's going to set up our reference and our on click, and that should do it. Let's see what happens. Oh, we got a little error. Parsing termination. Unterminated JSX content. So okay, so we just have to clean this up a little bit. We have an extra div here. We just need to close it. There we go. Now we're back to 1 square each. Okay. And everything seems to work except for our references. So for some reason, this part is not doing quite what we want. Let's see if we can figure out why. I'm gonna search through my code a little bit here. Did I type it in right? chessboard refs ID equal ref. And what we can do is, actually, I think I know what might be happening here. So by using this ref thing, I think we're falling into a situation where React, now that we've pulled this out, React is sort of, yeah, React is probably outsmarting us a little bit by deciding that the state hasn't changed enough to actually re-render this. So one of the things that we've run into here is we're sort of not thinking very Reacty by using these refs. What we're doing is, the thing about React is it's not necessarily, as far as I understand, going to call render on the entirety of the thing. So whenever you have something that's a different component like this, React is smart enough to know that it doesn't actually have to change any of the rendering if set state doesn't impact that thing. So the fact that it's not actually drawing our change to our class list probably has more to do with the fact that set state is getting into this thing, and it's seeing this and going, oh, there's nothing in this list that was changed when set state called. So none of this is going to get re-rendered. This is going to get re-rendered, but none of this will. So let's save that for the next video. We're going to go over how to think about this in a little bit more of a React way, because it's not necessarily a very Reacty thing to do to use this reference system. It's sort of an abuse of React references to do it this way. But that's a good stopping place and a good place for the next video. So before watching the next video, a good thing might be to think about how to solve that problem on your own, and then where to go next. What's the next little feature that we can add, or how can we chop this up a little bit and make it closer to our goal of what kind of a game we want to be. So thanks for joining me, and I'll see you next time.